are going to watch the insane engineering of Marine One. So Marine One is the helicopter that carries the president from, I think so, one place to another inside his own, nearby White House or inside nearby cities or somewhere like that. Because we know that they use Air Force One to travel between the countries. So it will be very, very interesting to see like what are the features of Marine One.
Actually, I am also very interested to see about this helicopter. But as per the facts, or I have read it, I was actually amazed and shocked by the fact that this same helicopter was tested 3 years, like 3 years continued, it was failed. And then
Wow.
now it is the only helicopter that the president is using to travel.
Oh, that's crazy because normally we see that, only the best of the best can go to the president.
Actually, yes.
And like something that has failed 3 times is going to the president is very crazy.
Very nice.
So it might have some really good features. So
Yes.
let's watch this.
Video.
This is the new Marine One, America's most advanced presidential helicopter. However, this $217 million
Wow.
helicopter
217 million?
That's a huge amount.
And I've heard, the planes, the commercial jets that we have, the planes that we fly, they are about 30-40 million.
What? This is actually crazy.
And the expensive ones, the bigger ones are like 80-100 million. And this is 200 million? This one helicopter that can only carry one president.
got so
that too, American one.
over-engineered
Wow.
that it almost didn't make it to service. It scorched the White House lawn, failed its communications tests, and got called not operationally
Not
suitable
operational.
by the Pentagon. Now its innovative engineering is the only thing between the president and a very long walk to Air Force One.
Oh.
The helicopter you see waiting on the South
Okay,
Lawn
okay.
is now a Sikorsky
I have a doubt here. This helicopter is used to just take him to the Air Force One.
Yeah, because there is this whole Pentagon thing where he sits
Yes.
and where he makes all the plans, and then there is the airstrip, the airport.
Okay,
So they take him there with this.
Okay. Take it.
He's the president. He won't go in a car
Patriot,
like us.
and it has no problem
We
that
are
no commercial
less rich,
helicopter
I mean.
has ever
Okay.
faced. The civilian S-92 it was based on was made to carry oil workers to offshore platforms.
Oh.
Tough conditions,
Wow.
demanding flights, but straightforward requirements. Get people there, get them back, don't crash. Sikorsky designed
Simple.
it for reliability and efficiency, and airlines around the world trust it for exactly that. The VH-92A started with those same bones, and then the Marine Corps added requirements that pushed the airframe to its limits.
Oh, like what?
Armor plating surrounds the cabin where the president sits. Ballistic
Armor
glass
plating.
fills the windows. Each
Of course,
pane thick
bulletproof.
enough to
Bulletproof,
stop
yes.
rifle
Simple, they
rounds,
should-
but heavy enough to cause performance with every square inch. The fuel tanks are self-sealing, designed to close around punctures rather than spray jet fuel into an engine fire.
Oh!
Redundant
Wow.
flight computers.
Oh, how does that work? Because normally if there is a puncture, so it's like
I guess it will crash.
no.
No.
But what he's saying is like when there is a puncture, it will like move around and it like save itself from like splashing the water or splashing the fuel.
What?
Yeah, that is the best feature of this.
Crazy engineering.
Redundant hydraulic systems, redundant everything, because Marine One doesn't get to have single points of failure. Add the classified
Oh.
communication suite, the defensive countermeasures, the electronic warfare systems, and suddenly you're looking at an aircraft that weighs nearly 27,000
Okay.
pounds fully loaded.
Oh my
The
God.
commercial S-92 tops out at around 24,000.
Crazy.
3,000 pounds doesn't sound like much until you understand what it means for a helicopter. Fixed-wing aircraft can compensate for extra weight with longer runways and higher speeds.
Yeah.
Helicopters can't. They have to
Yeah.
lift straight up, hover in place, and land on a patch
And
of
you know
grass.
why I always feel that helicopters are not so safe? I don't know why I have that feeling. I can sit in a airline 100 times, but
Okay.
I cannot sit in a helicopter because it just feels like it is very flimsy. But this one looks like very heavy duty.
Exactly. The question I am having is how it is manageable to take a lift from the ground. It is so much heavier in weight and it's crazy.
Crazy engineering.
That's no bigger than a tennis court. The rotor system that worked fine for the S-92 now has to work harder. The engines that provided comfortable power margins now run closer to their limits. The transmission that transferred force smoothly now absorbs more stress with every flight.
Wow.
If you look at the VH-92A sitting on the South Lawn before its trip to Andrews Air Force Base, it looks almost identical to the civilian version. Same fuselage shape and rotor configuration.
Everything is same.
The only difference is the iconic white top, green bottom color scheme that Marine One has worn since Eisenhower. But underneath that familiar exterior, engineers rebuilt nearly everything to handle the weight the original design never anticipated.
Wow.
The VH-92A runs two General Electric CT7 8A6 turboshafts, and they're working harder than the commercial version would ever tolerate. Sikorsky's engineers faced a choice when they added 3,000 pounds to the airframe: accept reduced performance or push the engines closer to their limits.
But they will never accept the
For a
reduced
helicopter
performance.
carrying oil workers, reduced performance might be acceptable. For a helicopter carrying the president,
Never.
it's not.
President.
They chose to push. And this push will become one of the biggest issues with the helicopter later on.
Exactly.
Wow.
The CT7 produces about 2,500 shaft horsepower per engine,
Crazy.
giving the VH-92A over 5,000 horsepower total. The civilian S-92 uses the same engines but manages them conservatively. Keep temperatures low, keep stress manageable, extend the time between
But not so
overhauls.
important job.
Marine One runs
That's
them
why.
harder. If a threat appears and the pilot needs maximum climb rate immediately, those engines will deliver it. The maintenance schedule absorbs the cost. Engine components get replaced more frequently than civilian operators would accept. But replacement parts are cheaper than swearing in the vice president. Here's where things get interesting. The system managing all of this is called FADEC, Full
FADEC.
Authority Digital Engine Control. And the VH-92A's version does something the pilot never could. Sensors throughout both engines monitor temperature, pressure, fuel flow, and shaft speed, feeding data to computers that
So
make
much of
adjustments
it
faster
together?
than human reflexes
Actually.
allow. When the pilot increases power, FADEC manages the transition to prevent temperature spikes that could damage turbine blades. When one
Wow.
engine starts running hotter than the other, FADEC rebalances the load automatically. The pilot tells the air.
So it's not that the pilot is the most important person. like,
Exactly.
computer is doing most of the job. Pilot is just doing
Wow, this was actually very nice. How if one engine gets heated up and it automatically rebalances itself.
Actually, and this is very safe for the president. Like our prime minister, I think so doesn't use anything like this.
Exactly.
He has a normal helicopter.
normal helicopter, normal chopper.
Craft what to do, the computers figure out how to do it safely. This matters because the VH-92A's engines are already operating with less of a margin than the commercial version. The extra weight means more power demand at every phase of flight, takeoff, hover, cruise, and landing. FADEC keeps the engines inside their limits even when those limits are closer than they should be.
Oh, wow.
Without it, the pilot would have to babysit engine gauges constantly,
Not
making
possible.
micro adjustments to prevent over-temperature conditions. With it, the pilot focuses on flying, while the computers handle the thermal management.
Wow.
The redundancy runs deeper than just having two engines. If one fails completely, the VH-92A can continue flying on the other. Reduce
One
capability,
engine?
but
Wow.
control. If both engines fail simultaneously,
Then?
the aircraft doesn't fall. The
What?
rotors keep spinning from
What?
aerodynamic forces as the helicopter descends, storing enough energy for a controlled emergency landing. The pilot uses
Wow.
collective pitch to cushion the
Whoa.
touchdown.
This is something very crazy for me because I have heard this for a flight. So if flight loses both the engines, it can still, it is gliding.
Yeah.
So it is coming down slowly, it can come down. But for a helicopter, that is it is going in the air.
Yes.
But the moment its engines are gone, it should like lose flight very fast. It should not like
Immediately,
go.
yes.
I don't know how it does that work. He did not
That's
explain
deep.
us that.
It's not gentle, but it's survivable. Marine One plans for failures that should never happen. Because should never happen isn't good enough
Wow.
when you're carrying nuclear command authority.
Oh yeah.
But 5,000 horsepower
Also Trump.
is useless if you can't turn it into lift. That's the transmission's job. And that's where the VH-92A's weight problem nearly broke the entire design. The main rotor on the VH-92A spans 56 feet and turns at 225 revolutions per minute.
Wow.
4 composite blades cut through the air, generating the lift that holds 27,000 pounds in a hover. On a commercial
That looks
S-92,
scary, you know,
this system
Exactly.
works
waving
with
in the air like
comfortable
that.
margins. On Marine One, those margins have been spent on armor and electronics, and the rotor system has to compensate. Each blade is built around a titanium spar, a structural spine running from root to tip that handles the centrifugal forces trying to tear the blade
Helicopters
apart.
also have a spine.
Fiberglass skin wraps the exterior in an airfoil shape, and honeycomb aluminum fills the space between. This result is a blade that weighs less than solid construction, but maintains the stiffness needed for precise control. The VH-92A's blades aren't different from the S-92s in construction.
Normally helicopters look so not well engineered because there is just a body and then there is this
Rotating fan type.
Yeah, that gives them the lift. But in the end, what we see here is like so insane
Yes,
engineering.
it's like small different parts. They are just combined and you get boom. This big vehicle.
But they're working harder. More weight below means more lift required above, and more
Yes.
lift means higher aerodynamic loads on every component. The rotor head is where the complexity multiplies though. Each blade connects to the
Rotor head.
hub through a system of hinges and bearings that allow it to change pitch angle independently, tilting up or down, twisting nose high or nose low, adjusting 225 times per minute in patterns that would look chaotic if you could see them in slow motion.
Looks magic.
When the pilot pushes the cyclic stick forward, the rotor head translates that input into blade pitch changes
Whoa,
that
the blades
tilt
can move
entire
like this?
rotor disc, pulling the helicopter in the direction of the tilt.
What?
The
I thought they
VH-92A's
were
flight
just for
control
rotating.
computers assist
Yes.
this process, smoothing inputs and preventing the kind of abrupt commands that could overstress the system. The transmission sits between the engines and the rotor head, and it's solving a physics problem that would otherwise make helicopters impossible. The CT-7 engines spin their output shafts at roughly 20,000 RPM. The main rotor needs to turn at 225 RPM. The transmission handles that reduction, nearly 100 to 1, through a series of planetary gear sets machined to tolerances
There are
measured
gears in this.
10,000ths of an inch.
My God.
The forces involved are enormous. The heat generated requires constant oil circulation. The VH-92A's transmission is one of the hardest working components on the aircraft, and it's handling more load than the commercial version because of the weight it's lifting. The craziest part is,
How?
despite this engine working overtime, Trump feels nothing.
What?
That's because the VH-92A uses active vibration control systems that the S-92 doesn't carry.
Not possible.
God.
I'd see the inside.
Oh my God.
Not possible because I have seen videos of helicopters and people like "Grrrr," they're
Exactly.
shaking. They wear headphones so that they do not get irritated.
Yes,
I have
yes.
seen that and
I've
like
also seen.
it is terrifying and it is very annoying to be in a
Yes.
helicopter. I have seen
And-
people.
And as a helicopter, I think that there are only few spaces for people to sit. There are just maybe 2 or 3 people can sit behind and the one
Yeah.
who is driving the helicopter. How can there be so much of space?
Yeah, this is better than many hotels.
Sensors detect oscillations from the rotor system. The actuators in the airframe generate counter vibrations that cancel them out. The cabin stays
Wow.
smooth
Mechanism
and
is
quiet
crazy.
while the
Counter
mechanical
vibrations.
systems above
Wow.
it work at their limits. This isn't just about comfort. Stable conditions matter when you're reading
How do counter
classified
vibrations
briefings. And they matter even more when secure
Too many
communications
questions.
equipment needs to function without interference. Vibration can degrade signal quality. Marine One can't afford degraded signals.
Oh.
The helicopter is now crossing the National Mall at 150 knots. The Washington Monument sliding past the windows, halfway to Andrews. The president hasn't felt a single vibration, but the
Wow.
systems keeping him connected to the outside world almost ended this program before it started.
Whoa.
The VH-92A declared initial operational capability in December 2021. The president didn't fly on one until August of 2024.
Yes, this was
That
the
It took them
gap,
3
2.5
years.
years between technically ready and actually carrying the commander-in-chief exists almost entirely because of the communication suite. Marine One has one job that
Communication
no other helicopter in the world shares: maintaining nuclear command authority in flight. The president must be able to authenticate its identity, receive threat briefings, and issue launch orders from the cabin of this aircraft.
Launch
the
orders.
communications
Okay,
links
so there was a
connecting him to the
communication issue.
Pentagon, to Strategic Command, and to the National Military Command Center have to work flawlessly. Encryption has to be unbreakable. Transmission has to be instantaneous. Redundancy
He
has
needs
to
everything
cover
just
every possible
fingertips.
failure mode. The VH-92A's communication systems were designed to meet these requirements, and they failed testing repeatedly. The specifics are classified, but the broad strokes became public. Encrypted channels didn't perform reliably. Systems that worked fine on the ground malfunctioned in flight.
Oh no.
Integration between components produced unexpected failures. The Marine Corps kept testing, kept finding problems, and kept sending the aircraft back for fixes. Meanwhile, the president flew on VH-3D Sea Kings that have been in service since 1974. Ancient airframes with communications technology that had been upgraded so many times, the wiring diagrams looked like abstract art. What finally made
Oh
the
my God, that's
VH-92A
crazy.
work remains undisclosed, but the capability it provides is clear. Secure voice channels connect to military and civilian leadership worldwide.
Wow.
Encrypted data links transmit documents and
Like,
intelligence.
the meaning is like the president still needs to feel like a president when he's even on the helicopter.
Exactly.
It's not like he is like, okay, disconnected from the whole world. If he wants to fire a gun and tell anything, he can do it from there and
From
there.
there and there. Yes, I guess this was the only issue. That's why it took 3 years.
in real time. Satellite uplinks provide coverage over oceans and polar regions where ground-based systems can't reach. The aircraft carries
Oh.
multiple antenna arrays with overlapping coverage because losing signal isn't an option.
Is the Wi-Fi
If
free?
one system fails, others take over. The president stays connected no matter what. The cockpit reflects this communications-first design philosophy. 4 glass displays dominate the instrument panel, replacing the analog gauges of older helicopters with screens that can show anything the mission requires. 3 independent flight computers cross-check each other constantly. If one produces anomalous data, the other 2 override it. Navigation runs through GPS primarily, but inertial backup systems track the aircraft's position using gyroscopes and accelerometers that need no external signals. If someone jams the GPS, Marine One keeps flying on dead reckoning alone by calculating its last
Oh,
known
so they
time.
That
always
is nice.
go in pairs. So 2 of them fly together. So that again with the same thing, 2 cars, 2 things, 2 Air Force One.
Yeah.
So that people cannot guess in which president
Which
is.
president is?
Time, speed, distance, and advancing forward. The VH-3D Sea Kings, the VH-92A replaced, were technological antiques by the end. Their basic airframes dated from the 1960s. Their communication systems had been upgraded piecemeal across 5 decades, layer upon layer of modifications that introduced complexity and failure points. The VH-92A was supposed to solve this with clean sheet integration, modern systems designed to work together from the start. The execution took longer than anyone planned, but the result is an aircraft that does what Marine One actually needs to do in 2025.
Exactly.
This helicopter is an engineering marvel because the way it is and the way it is built and the way it is engineered is crazy. Because I have seen, even our chief of defense staff, Indian's chief of defense staff
Okay.
recently got killed in a helicopter crash.
Yes.
And he was like in a normal helicopter. So I think so like that was one thing because we lost that guy was very important to us and we lost that guy just because of a stupid helicopter and also because of the weather. So this helicopter I think so can go against any weather and it is like ready to face anything that comes in its way.
Exactly. I would also love to talk about the manufacturing, the engineering. It was on top. And secondly, I would like to see the president, how he plans the failure before the success. For example, we'll talk about this helicopter. He planned like what will happen if it fails first. He is so like it's actually mind bending the way he thinks. Also, the fact that they are always in a pair. The helicopters, the jets, the cars. It's nice and it's actually good for the safety.
So that the killer is also always guessing like which one to choose.
It's
and
always
which
a
one to-
bluff and a guess game and which one is the president.
Actually, so how did you guys find this video? Do let us know in the comment section below. So do like, share and
Subscribe.
Bye.